great guys. So first of all, how many here have seen problems like, performance issues, production is down? Oh my God, you are at the right place at right time because I am going to talk about the same subject because algorithms are all part of this, and this is going to be a more of an interactive session which I want to take it further. So as you can see, this is a near and dear to your topic and my topic. So what's really happening is we are trying to create efficient architectures. We are all trying to create efficient architecture, but forgetting the algorithms. Isn't that true? Like, we learned the algorithm some time back, so I'm going to bring that back in as part of my journey for 1 hour with us today, right? Is that a good deal? Yeah? All right, so let's get started. So I'm just going to give you the steps of the algorithm. Instead of just saying that, hey, I want to do few things, I want to give you steps to follow to really do any problem given to you. And then these are some of the other algorithms which are there, including searching, graph algorithm, dynamic programming, pattern matching. We'll see how much we can go today. But the perspective is once you understand the steps, it will become much easier for you. So as you can see, there are 7 steps. There are 7 steps for cracking any, coding interview. Let's call it this way. But this is actually more than that. It's not just coding interview, guys. The important thing is I want you to understand what questions to ask whenever any problem is given to you. Does that make sense? If you are able to understand the problem, that is 80% of the problem in the solution. So that said, this is one of the good books I suggest. If you don't have it, you can buy it. I'm not getting anything from this, but this is a really good book to buy. Cracking the coding interview. It will give you an understanding and build your steps further. All right, so Einstein, this is not me saying, Einstein saying, if you have 1 hour, 55 minutes, think about the problem. That's the important part. And one thing what happens is that we miss out on that part of it. The problem is analytical skills. Analyzing what is being given to us. What is my need state looks like. What is my coding skills? Coding is part of it, but that's not the only part which we are here for. Technical skills are needed, but whenever we are doing something, there is always a communication gap. What we are doing is we are using a hashing algorithm. When we are using the hashing algorithm, the hash function used here and the receiver is different. How many here know that problem? Yes? You get a problem, you don't know what the hashing functions are different. So what we need to do as part of a solution to make sure the hashing function remains the same, all right? So in that case, we need to analyze the problem, understand what the cost and the time optimization is, and start thinking on paper first. That's the first thing I suggest you to do. Never, ever, ever start doing, hey, let me Google this problem. That's the first thing we all do. We look at the problem, okay, let me Google it. Let me find out who, somebody else must have solved this. Instead of doing it on the paper, that really helps us out. Understand the different components. You're trying to create a component and then try to use that particular component. You want to make sure that the needs are maintained. Needs means when you have different algorithm, what's my input, what's my output looks like. And then now I'm asking you to not just think logically, but creatively. Wow. What that has to do with algorithms. We'll talk about that, what that means. And then, of course, you need to do some mock understanding. Mock challenges. I will give some mock challenges, but there are mock challenges which are available for you to use later on also as part of the detail. And then you need to listen to every detail. Once you understand the need state of the problem, now what we are trying to do is we are trying to draw a specifically large example. When I say large example means that don't try to say that, oh yeah, I will solve this problem without actually creating a sufficient large amount of data. So that's another thing which is important. Now it comes is the designing of an algorithm. Now optimization comes later. You don't want to optimize it right away. You want to make sure you solve the problem first. Hey, somebody said that I only got 100 input. You got 100 input and output, that's it. So in that case, if there are 100 elements, doesn't matter it's n square or n and cube you are using. But if the performance needs to be more for making sure that you have the right context to working with it. Okay, then we need to modularize. You have to modularize the design. When I say modular design, that means you are creating different components, which you can now plug and play with each other and test your code. Testing is another thing which is very important when we are working on it. And who is going to test it? Testers, yeah? Testers? No. You kick it to them. They're going to test it, yeah? No? Okay. Yeah, so this quality control is not responsibility of a tester, just to let you know. So there's something which we miss out on. So when we say testing, read it line by line, find out, understand, analyze the input, output, boundary conditions for that, scrutinize what parts are there, what parts look good, what parts look bad, and check for the spots for the errors. Now that way, and now you're running the test-driven development, where you're writing the test, TDD. You know, Venkat, if you go to some of his sessions, he talks about a lot on that TDD, and you know, so something very important to do. And then of course you want to fix the issues behind the scene. But when we are trying to do the test, we want to test with different scenarios. Something we miss out on. And what's the first thing we all say? What's the first thing we all say? Anyone? I need production data. Isn't it? Ooh, how can I get a production data? Get me production data, I'll test it. Yes? Everybody say that, yes? It's not me saying it. It's like everybody says the same problem. So what you need to do is you need to look into these two tools. I would not spend time on these guys, like, because you guys can try it out on your own. It's a Mocaro. Mocaro is a tool which can actually output, if you give an ID, and then first name, last name, it's going to output the whole data for you. That means with object relationships also maintained. And if you put the credit card number, it will generate the credit card numbers for you. Isn't that cool? It's an awesome way to connect and start using it. So one thing I suggest doing is to use Mocaro. So I'm going to try one time, guys. So this is what happens. Performance and efficiency is part of it. We are trying to see if the internet works. How exciting. And that's what happens. You are going to bound to have a problem like this. But this is very real. You know, and then you may say that, hey, my internet is not working. That's perfectly fine. The internet does not work for 20 minutes. There is no problem. It's your responsibility to make it work. Simple as that. If you cannot even create a ticket at AWS, anybody here from AWS? I can ask that question to him. But not only him, like for any other cloud vendor, you can't create a ticket. If the server is down, you should still work fine. So that's still a problem we need to resolve. So this is one tool which I suggest you guys to use when you're building the solution. Another is generatedata.com. In generatedata.com also is an excellent tool which you can use. It will now give you large amount of data to work with. That's the awesome thing about it. Yeah. Now let's take a look at algorithm. What does algorithm has? We all know. Input, garbage in, garbage out. Yes? What is input? If I don't know the input, output does not matter at all. So that's the problem. So when we say input and output, you want to make sure it's clear, unambiguous, and well-defined input and well-defined output. And now when we are doing that, it's making sure that, hey, it's not Java dependent. How many here Java or JavaScript? C#. Yeah. So it does not matter which language do you use. It can work for all the languages without any problem. The important thing is that algorithmic complexity is something which we have to understand. Now we say that, oh, this is algorithmic complexity looks like. But really speaking, let me explain you what that means. What that really means, I'll just talk about that. So what's really happening is that now in this case, you have your microservice, okay? This microservice is calling another microservice, is calling another microservice. So what's really happening is You're just having one for loop. I'm cool. You're having another for loop here. So how many for loops do you have? Okay, let me write down one more time. Let's do the math again. One for loop here, two for loop here, and three for loop here. You have three for loops going on here. Now, because you're creating microservices does not mean that it does not need to be atomic. Does that make sense? Yeah? So this is a problem which I have seen in many, many projects where they said, hey, I have written a very atomic code. I can save the customer data without any problem. That microservice works fine. But really speaking, who's calling it? And does it have the context of that while saving it? So you do the save only once. That's the important thing. You got to save only once. So what happens is like your JDBC batch execute is there. There are other performance optimization is there. Don't save the data, but save all the data, cache the data, and then save at once. That will actually save you a lot of time and trouble while doing it. So we all know about our logic here. So let's take a look at what's really happening is the more you go up, the higher the reward you get. N cube means more reward, yeah? That means it's the slowest, slowest query. Reward means when you're in a production issue is going on, this is where the production issue comes in, like when you have n cube complexity of the code is there. So what you need to do is, you need to identify these problems. Now these are not straightforward, that's why I'm saying, like if it's just one loop, like in one code, it's easy, yeah? But if you're having dependency stack trace, how do you do that? That's the important thing. So of course you want to avoid n factorial. Yeah, nobody should do n factorial, unless until you're just playing around, to save some of the problems. So that said, you can add these for loops to do, okay, how to find the two arrays if two arrays contain any common item. So that's the question, A, B, C, D, E, and F, G, C. So in this case, there is a C is a common element here. How do we find it? Anyone? Come on, start. How are you going to find this? Yeah? Two calls, yeah? Two for loops, yes. Anything else? Huh? Sort the array, yeah? Very good, very good. Anything else? Hash map? Hash map, awesome. Awesome, 1, 2, 3. What did you miss? What did you miss? Write down the details. What happened to that? So this is a time for laughter because this is a disaster. This is what happens. Hey, I know how to solve it. Yeah. So what happens is, what's the input? What's the output? What's the maximum size? Oh, if I told you 2 array logs are there, 2 million. Input is 2 million. How are you going to do that? So then the answer is different. You can't do it. So that's where what's most important? Time, space, and memory. Depending upon that, if I'm saying 3 billion records are there, and you have to do some jugglery on that, you can't use it. It's not possible. Big data, guys. Big data is petabytes of data is there which you're trying to use in this case. Now I'm going to just go through really fast because we all have already solved this problem. So what we're going to do is brute force. We're going to go through the algorithm here, which is saying that, hey, I'm going to go through the for loop here. I think I don't even need to go through the for loop. We all know, like, hey, you can go through the for loop and find out n square is the complexity for that. Now, memoization is a greater technique, very good technique, which I have used a lot, which you can use per session basis to really improve the performance. Now, memoization is as if, like, you have an input. If the inputs are the same, the algorithm should give the same output, yes? Yes? So if that's the case, any input coming the same, you cache that data. That is the greater way of really helping out. There are many ways to do that. You can create a hash map. There's something which we talked about here. Or you can create, in this case, I created a variable. That's the only difference between the two. So negative tests. Now, another thing is asking the data-bound question, asking the field size. What's the field size look like? What the numeric boundation is there? And then modification you need to do for the performance, like how you run that test. That's another thing which you can do in this case to really solve this problem. So now, as you can see, I'm writing out all the negative tests which are there. So you have to find out different types of tests which you can run. Anybody here knows about sanitizer? Sanitizer? So you can do the data sanitization, like address sanitization. Those are other types of tests you can run to really solve that problem. So I wouldn't go over in detail, but if I'm using a username, it should be blank, should be percentage, what should be the password size, how it should look like. All that data is part of your analysis which you have done beforehand. Okay, another question for you guys. Check for a pair in an array with given sum. So 1, 5 is 6. So how do we solve this problem? Huh? Use a hash map, yes. Again? 2 pointers, yeah. 2 pointers, yeah. 2 for loops, yeah. One of the elements. I am looking for some other question. Huh? Huh? So the question is, now you started asking me questions. Is it a sorted array? How big is the element? You have to ask me questions. Is it a negative value can be there? A positive value can be there also in this. So this is just a simple example I'm giving you, but this, while giving these answers, you will come to know, oh, I did not take care of the negative case. I did not take care of the, some of the arbitrary cases in this case. Contain some duplicates. Can there be a duplicate? We can also say, yeah, there could be a duplicate here. So that could be another problem which comes in. Now, if I revisit that same problem again, now I got a different set of data. A lot of data is there. Now I'm able to now come through and find out what the pair looks like for it. Yeah. So that's one way of making sure you have a sufficiently large amount of data. Make sense? So that's something which you have to keep in mind when you're building it. Okay, so brute force looping of the function, easy. Yeah, we all know about that one, n square complexity. And then another is you can do sorting and binary search. So sorting is an algorithm which you can use, and depending upon the different type of sorts, there are 2 main sorts are there. Merge sort is there, and there is another one called heap sort. Both are really good for the sorting functions. We'll talk about that in a second. After that, you do binary search. So that is another great way of building the solution. Hash table is another one we talked about, which we can do. Okay, let's talk about this one. We need to find out between the most water which is contained between the two values. So if you see here, the most water is between this limit and this limit. That's where the most water is, 49 is there. So how do we do that? This kind of problem. Anyone? Sliding window, yes, awesome. Next largest, and you can go both ways you can go and then find out what's the largest value looks like. But before I do that, I'll also do the play with the person, like, hey, find out what's the maximum size and negative value and positive value. The perspective is we need to find a sufficiently large amount of values. That's the main thing which is important here. Now, important thing here is that what we are doing is we can have 2 for loops, easy, like that's going to be the n square solution. But in this case, what's really happening is that now I'm finding out the lowest number and finding out the maximum out of all these things. Yeah. So here I'm actually changing the pointers on both sides, left side as well as the right side. Yeah. And then finding out which one is the switch. So this is basically which we use for the shifting pointer solution, where we say that, hey, calculating the maximum area between the 2 values. That's the way we do that. Okay, this is another problem, backspace string compare. Backspace string compare means like when you have a string when you are comparing the string, when you do a backspace, you want to make sure that A, B, hash, C. Hash means backspace, and then C. So this means this becomes A and C, AD hash C. So this is another kind of problem which is there. So what can you do in this case? Anyone? Using stack? You can use stack here, yeah. What else can be used? So what we are doing is we are creating a backspace and then we are adding that value, yeah. That's what we are doing in this particular case. Brute force is the easiest thing to do, but in this case also you can do two-pointer solution. Two-pointer solution is like, you're trying to create reverse string. Reverse string means you're starting from the backside, and if you see a hash, then you skip the next character. So that way it becomes O of n. Like, that way it becomes like, faster solution for us in this case. All right. So I want to do one thing is I want to go ahead and talk about something which are critical for us to look at. Okay, let's start with the binary search first. So binary search is a greater way, like, if you want to find out any of the elements, which, like, hey, you want to sort this. Once it is sorted, you want to find the elements. So this is one way of kind of solving easier problem, yeah. But what you can do is where all we use it. That's my question. Where do we use the binary search? Sorted array is fine, but where actually application-wise you use it? He's saying whenever we need to take a decision based on some value. Yeah. Anyone else? Where do we use it? Finding a chapter in a book. Yeah, that's a good way of putting it. So you can use it in a lot of problems, like find out the frequency of a given target value in an array of an integer. So you want to find out a target value. A rotated array. If you want to find out a rotated array, you can also use for that purpose. So dictionary, you can do debugging using that. Git bisect. Anybody use git bisects? Yeah. So that's another thing which you can do in this case. All right. So after this, we're going to go to graphs, guys. So I'm just going a little fast because this is straightforward from that perspective. But right after that, we'll be looking at some graph questions. So which one is a better sort? So merge sort is the fastest sort, you can say, if the space is not the limitation. Okay, if the space is not the limitation, then the merge sort is the fastest sort. Java actually uses merge sort behind the scene. But if the space is limitation, then I'll tell you another sort which we can use. Now in this case, what we do is we basically go in, divide it into two different halves, and then what we do is we go all the way down. In this case, we are going 38, as you can see here, and be able to do the merge sort. Now what we are doing is we are now sorting the lowest number on the left side and then having the sort created here. Yep. All right. So, okay, so this is something important for us to understand. So remember I said that about this one. So merge sort is n log n. Okay, merge sort is what? N log n. Now if I want to use, and I said that I'll give you another sort, which is heap sort. Heap sort is n log n throughout, but the space complexity of O of n. So if you have millions of rows, in that case, it's better to use heap sort. Yeah. So that's the one thing to keep in mind when you're building the solution. Okay. So I want to just talk about now is quickly about hash functions. So hash functions is another good way of doing it. So now when we are creating a hashing function, Now, we are creating a hashing function, which, why do we create a hash, by the way, hash table? So that we can quickly find out the values, yes? That's the reason we kind of do this. But the problem comes in, like, whenever we are having separate chaining. So what happens in the hash function, this is what happens, something like this, 85, and if the same hash is used, then 85 and 92 is also added in this case. That's one thing which takes place here in this case. All right. So let's talk about binary search tree. So BST is there, binary search tree is there. So now, when we are using binary search tree, what are we trying to do in the binary search? We have association between different nodes, yeah? We want to find out the binary search for inserting and updating of the binary search, yeah? That's the reason we are using binary search. So can you give me an example of a search algorithm which is using a tree? Anyone? Huh? Indexing, yeah, you can do indexing. Anything else? Huh? Java map, okay. So whenever you are trying to optimize something, you are doing scheduling. You're doing scheduling. You are also using the map behind the scene. You want to prioritize the priority queue. Priority queue also uses the same map. Yeah. So in this case, what we are doing is we are trying to create a map. Now, map can be both balanced and unbalanced. Now, what happens is we want to make sure that we have a balanced map so the searching becomes easier. You don't want to make it an unbalanced map. So this is what we want to try to avoid when we are building this solution. Now, if the requirement is now there are two things which is there. One is AVL tree. So AVL tree can be used when we want to create a map which balanced tree. So when we want to create a balanced tree, what we can use? AVL tree. Yeah. So if the internet was working, I would have given you an actual live example for this. Apologize for that, but that's what double happiness is all about. The internet works or not works. But the perspective is that this is important because now you can create a balanced tree. Now it becomes much faster for searching also. Yep. Next is if the requirement is that, hey, I have got lot of updates are coming at the same time. Lots and lots of updates are coming. Frequent inserts are coming. In that case, you have to use red-black trees. So red-black tree is a greater and faster way of connecting and using a particular tree. Okay. Now, binary heap, if you can see here, in this case, binary heap, you see here, it's saying 96 is on the top. Yeah. When I want to say that, okay, I want to get the first value, it will give 96 out from here. Okay, 96 it will get out from here. In that case, what is the other number will come here? 79. Make sense? Now, where is it used? Binary heap is used. Just talked about it, yeah? Priority queues, yes. Yeah. So we use it for the priority queue. Yeah. So that's a good place where we are using this one. Right. Yeah. So I did talk about priority queue here. So you dequeue from this, and this is used in emergency functions and other functions also. All right, so let's complete the play with graphs. So now in graphs, what do we have in graphs? Like, everything is an explosion of graphs are going on at this moment. So if you can see here, we can have different types of graphs for us to use. We can have, so for example, whenever we are doing a search algorithm, we are trying to create a resource. How we are all connected to each other? It's all graph. Behind the scene, it's all graph. So we need a way of representation of the data while creating that particular decision. So anybody here see this one before? What is this? Contact tracing, yeah? So what happens in contact tracing? We need to find out who is in contact with another person. That is all created using graph, yeah? So that was another one which was created. Now, if you need to find out similarity between two different nodes, if you need to create similarity between the two different nodes, we can also use the graph. Now, anyone here know Instagram? Use Instagram or Facebook? Yeah. Now, influencer is the person who is influencing the topic which you are trying to create. So, if we need to find out who is the influencer within a graph, how do we do that? Using the graph functions. Yeah. So we can actually find out the influencer who's the most influencer. So this is called undirected, unweighted graph. Now, we can find out the most influencer is 2 in this situation, or 1. Yeah? Now, where do we use this? Anyone? Where do we use this one? Where do we use this graph? So if you want to find isolated people, 2 different networks can be connected with each other. They introduce each other, and then you get more sale of the product. So that's where we can use this for. This is a visualization of the whole internet. It's something called as Opti project. All graph, like all linked to each other, which is really interesting. Maze functions. Maze is something like, think about maze also as roads, yeah? So roads are closed. So our maze, like when we are using Google Maps, yeah, it is finding out what is the possible paths and the fastest path to go through. So you can also use maze for that purpose. Social distancing, we talked about it, yeah? What's the shortest part between the 2 nodes or 2 people? If you want to find that information, you can use this for. Where is the mutual interest? Wherever the mutual interest comes in. Now, disjoint graphs is also very common. Disjoint means like they are not connected to each other. Like maze problems we solve using this one also. Calculating mutual friends between 2 different networks. Now, this is also used for calculating the minimum spanning tree. So minimum spanning tree, it is also used for finding this information. Now, if you remember, like Christmas comes or Mother's Day is coming, yeah, you remember? So we always purchase some gifts, yeah. So how do we do that? We purchase the gift for our loved one. That's also a type of a graph, where we are finding out, hey, I need to now buy gifts. So this is what I'm saying is that I am buying the gift for my spouse. So this is directed graph, because anniversary is coming. If I forget, then it's a problem, So that's another thing which you can do in this case. Okay, this is a transportation graph. Transportation graph is saying that, hey, I have a node. If you see here, 2, 4, 1, 2. This one will be the fastest way to go. This will be the slowest way to go. This is used by Google Maps. Time and distance, it calculates and find out a way of finding out this information and using it. Another is a tree graph. So tree graph is like, we looked at lot of trees are there, graph traversal. We can find the shortest path between the 2 nodes. We can use this also for. Now there are 2 different types of searches are there. One is depth first search, and one is breadth first search. I mean, this is something which we all familiar with. Where do we use depth first search mainly for? Anyone? In UI, if you are using the UI, you mean to say, okay. So you want to find out, does the past path exist? Does this path exist? Okay. If that's what your premise is, in that case, you're using depth first search. Okay. So you want to find out the breadth first search you are using to find out the shortest path. If you want to find out the shortest path, so this is used. The main difference here is I need to know A and B needs to know where to go to C. So I have extra information added. So this is it requires more memory, but it is faster to find out the shortest distance. Okay? So what that means from depth first and breadth first search, the important thing is it uses the less memory. So this one uses the less memory, that depth first uses the less memory, and breadth first use more memory. And it can get slow if you are using the other one also. Now, knowledge check. If you know a solution is not far from the root of a tree, which one are you going to use? Huh? Depth first search? Breadth first search. Yeah? Breadth first search, yeah? Okay. If the tree is very deep and solutions are rare, depth first search. Why not breadth first search here? Because it's going to take a lot of memory to keep all the data. Yeah? So if the tree is very wide, huh? In that case, depth first search we need to use. Yeah? Okay, so let's if the solutions are frequent but located deep in the tree, depth first search. In that case, we need to use depth first search. Determine if the path exists. Remember I talked about this, yeah? Depth first. Does the path exist? Is depth first. Make sense? So that's something you have to keep in mind. Find the shortest path. Find the shortest path. Breadth first search. Yes, that's perfect. Yeah. So knowledge check, so we already talked about this one. If the solutions are rare, so breadth first search, and depth first search for this one because breadth first search because the depth first search will take a long time, a very deep solution. Yeah. So both of them can solve the problem, but something to keep in mind. Cyclic problems. You're going to have cyclic problems. Trading currencies. Why this is important? Cyclic problems. Where do we see this? Huh? Repetitions, yeah. Trading stock market, you mean to say? Yeah. Stock market has a cycle which is going up and down. And you're going to make millions of dollars if you know that, oh, this is going up now, okay? So you're going to get a lot of money if you know how to, if you can predict this, it's very useful. Now, what to use for detecting cycles? Detecting cycles. Depth first search, okay? Because we are doing the depth first search, does the path exist? That means I'm going depth first search and finding out if there is a cycle there, I'm finding it out right away. So that's the reason we are using the depth first search for this purpose. Cycles are very important. We need to identify the cycles and kind of remove those cycles when we are working on it. So cycle detection, if I had the internet, I'll showed you this particular example also, where we are trying to find out. What we do is we are trying to create here. Cycle detection was one example. Okay, so this is another example where I need to go from hit to cog. So I changed only one letter. It became hot, dot, dog, cog, log. So what is this? What is this saying? Now I'm going to read this to you. Okay, given two words, word 1 and word 2, and dictionary DICT. Write a program to find the length of the shortest transformation sequence from word 1 and word 2. Shortest transformation, what am I going to use? What am I going to use? Breadth first search? Yes, breadth first search, yes. Because it's the shortest path which we are trying to create in this case. So so yeah, breadth first search we're going to use. So what we do is we create the tree structure, then we create the adjacency list. Like for example, log and dog is star OG. So I create the adjacency list between all the functions which are there. Once I do that, I can find out that information. Another problem is time needed to inform all the employees. So think about this. This is from the top, CEO decided doing something. Now they are saying that, okay, it's going to take like 1 day for senior managers to, to VPs, to senior managers and to the employees. If you want to trickle it down, it's going to take time to do it. In that case, what are you going to use? Depth first search, yeah? Not breadth first search in this case. So that's pretty much what is important from this perspective to understand. So now in this case, what we did was we found out what's the maximum time it will take, because and then we are just going down and finding out that, hey, this is the value is 4 in this case. All right, let's take a look at Uber as an example. So Uber, what the Uber did was like we go from one place to another place using Uber, yes? So what is Uber really doing? Uber is creating Uber Maps. We are creating Uber Maps. And in the Uber Maps, what it is doing is it's having Google Map, plus it's adding its own intelligence on top of it, yes? What is it adding? Anyone? What is Uber adding? Shortest path is coming from most of the time it's coming from Google Maps. What it is adding is access points. Okay, so access point, it's adding access points. So what it using is using something called the Map Cruncher 2.0. It's an algorithm, by the way. This is written by Google. So what it does that within a distance of a parking lot, it finds out how many cars are there within that parking lot. Now that becomes what? So this, in this case, cell 2 becomes what? A partitioning key. You see? So it became what? It became a partitioning key for you. Now when you want to search for that particular partitioning key, now you are able to get how many drivers are there nearby my location. All right? That's the reason we are using this, this particular function. So now what happens is, the first thing what happens here, first thing what happens is that this is my building. Let me make it a little bit easier to understand. This is my building. In this building, these are my access points. I am in this building right here, somewhere in the middle, in a downtown, I'm somewhere in the middle here. It needs to first calculate which is the closest, what? Access point. You need to calculate that in what? In memory, in milliseconds of response time. So I'm talking about really fast response time. In that case, it uses Spark to calculate it in the memory and does it really fast using Spark. And then it finds out, okay, this is the shortest distance. Do you want to be getting picked up from this? That's what you're using. That's the reason you're using Spark for this purpose. Okay. Now, the another thing is called directed acyclic graph, DAG. So DAG is what is used by Spark. So what's happening is that where you are always going in one direction and you're trying to solve that problem in stages. So remember, it's always good to do problems in stages, and then you can recompute that same problem again and again. So algorithm also you can do that. That's the reason DAG is used. So for example, Git, if you made a mistake, either you find out using git bisect where the problem took place, yeah? That could be one thing. Another thing you can see here is you can actually correct that problem. And then it creates a SHA. This is also another type of a DAG, directed acyclic graph. So what happens, any compiler, scheduler, prerequisite tasks, like, for example, Maven is there. So it all uses the same function. So what it does, it finds out, in this case, it finds out something like this. So what it is doing is, it's trying to compute the values from the database, it got it, and it calculated those values, and it produces a map out of it, and it's reducing afterwards. What happens, this is the question to you guys, what happens if at this stage, when I'm trying to combine from two different sources, it fails. At this point it fails. What happens in that case? It will not recompute. It will start from here, from this stage, and then goes up. That's the advantage of using resilient architecture to build using DAG, directed acyclic model. Make sense? That's the reason we are using RDD, which is recomputable model you're trying to build, and which is fault tolerant from your perspective. This is another example of sensor data. You get the sensor data, you get the summarization at the per second basis, per minute basis, and then you have a critical status created, done in stages. This is also another type of a graph. Batch processing is also a type of a graph, which in this case we are trying to process currency data. Topological sorting. So let's talk about that for a second. So topological sorting is used in a lot of industries. First of all, like in any compilation task which you want to do. Any compilation task we want to do is we are using topological sorting for that. Okay? So this is one Maven dependency resolution. Yeah? So what you do is same thing what we talked about. In the topological sort, what it is doing is it's first trying to put everything in a stack. Okay? First, it's trying to put everything in a stack in a format that the independent components are processed first. Independent components are processed first so that the dependent components can be processed later on. Does that make sense? Yeah? So independent component, dependent component are processed later on. What it does is it finds out that the J can be processed first because it picked it from here, but it put it in the stack. H is the most dependent, so you put it in the stack first, and after it gets from the stack, it takes the stack out, and this is the sequence in which you have to process the records. Make sense? So this is what is used in scheduling. So if you want to create efficient scheduling algorithms, in there you would want to use this algorithm. Make sense? That's one thing which you do. Core scheduler is another example which I had, which we could use. This is called as a complete graph. So when I say complete graph, what this means is that why do we need to create a complete graph? To do the stress testing. When you want to do the stress testing, worst case scenario, if you want to build a worst case scenario, in that case you're going to use complete graph. This is another one called a Facebook Graph API. Now, this person has a birthday coming on November 5th. Yep. So now, who all are linked to this person, so we can now project them to buy a gift for them. Yep. That's what happens in this case. Now, weighted graph, directed weighted graph. So so far we talked about weighted graphs only. Now I'm talking about directed weighted graph. So directed weighted graph, what we are doing is, we are trying to create a spanning tree. So these are all the layers are there. This is an undirected graph. Now I created a spanning tree of 2, 3, and 5. Is this minimum spanning tree? Which you see on the right hand side. Is it? No, it is not. It is not. It's not a minimum spanning tree, because if I don't use 5 and 2, if I just do 1, 3, 1 and 2, in that case, just don't use 5 in that case, I still get that. So this is the minimum spanning tree. And why minimum spanning tree is important? Because once I know what's my minimum spanning tree is, now I can calculate it much faster. Yep, that's the reason we use this. So this is where we are using Kruskal's algorithm. Kruskal's minimum spanning tree is used. So Kruskal's minimum spanning tree, what it does, it first sorts all the edges. See here, 1, 2, 4, and all the 2s are there, it's going to start processing 1. So if process 1, there is no cycle here. Process 2, there is no cycle. There is no cycle here. Process 4, there is no cycle here. I can also add the 4 here in this case, yeah? And then process 6, oh, there is a cycle. If there is a cycle, don't add that node. Don't add that node. Once we do that, now we created the whole thing, went through this whole cycle, and then came up with our tree where I'm not processing an extra node where there is a cycle coming through. This is what is used for finding out the fastest algorithm. Now if you see here, so this is called Kruskal's minimum spanning tree. You could also use, just like Kruskal's, you can also use Prime's algorithm. Now Prime's does not have any problem, like you can start with any node. If you want to start, you can start with any node and be able to process the record. And then basically you start with any node and then find out the shortest one. 5 is smaller than 6, so you're going to process 5 first, and then you're going to process 1. And process only the smallest one first. Okay, that's what it means. And if there is a cycle, don't repeat it. Period. That's what it does behind the scene. Now, where do we use it? Now, this is where the Dijkstra's algorithms comes. Dijkstra is created by Google. Okay. Now it is used. So if you want to find out from one place to another place you need to go, you can use Google to do that. Easy, yeah. Now, if anybody here from the service industry? Service industry, like electricity or appliance fixing at home, or appliance fixing. Service person comes, AquaGuard. You change AquaGuard person come and they change the the filter and things like that. Yeah. So they are on a monthly maintenance or 6 months maintenance. Yeah. So there is a maintenance plan you have taken, and they are coming and creating this. They have to visit 20 places. Or 30 places they need to visit. You can put that same in this and then be able to create that. What that means, now the internet is not there, I would have shown this easily. So what I'm doing here is, it will find out, I'm starting at 8 a.m. in the morning. Starting at 8 a.m. in the morning, depending upon the condition, 10 minutes or 5 minutes, you are able to process and be able to use this system. Okay. Now the next one is dynamic programming. So dynamic programming, only one thing I wanted to say here. If you are using a recursion functions, memorize the data. It's very, very important. If you don't memorize the data, that becomes n factorial. So if the inputs are the same, if the input does not run, the same input is coming in again, you can cache that data in a hash map. That's the whole premise behind it. You can use it with factorial and traveling salesman problem also you can solve using this. Okay, the last 2 more algorithms will be done for today. So pattern search. Pattern search is there. So pattern search, when we are trying to do a pattern search, naive algorithm is I started searching from A, B, C, D, E, and be able to create that. But what you can do is you can also search based on the KPM algorithm. What the KPM algorithm will do? It will search the data based on the last character. Based on the last character, it's going to search the data when they are building this solution. So, and then we have trees. Anybody have used trees? Anybody use this? Trees? So this is used by any search engine. Whenever you are building a search engine and you want to do a fuzzy match also, you can use this. So trees is used for that purpose when we are building it, building this particular solution. Okay. Now it has multiple functions we can use for us. Okay, so the last one is, I just want to go over the knapsack problem. So knapsack problem always comes in like, when you have a constraint, hey, I can only put 15 kg. So when we need to choose the maximize the amount of money while still keeping the overall weight to be 15 kg. And then you can, depending upon the constraint, hey, you can only pick one, or you can pick as many of the values which you can pick. So knapsack problem is another one which is a constraint problem. Sometime is important for us to understand when we're using the system. All right. So I would just say that, hey, today was a quick revision of what one of my talks is. Apologize, the internet was not working. I would have actually showed you all these examples. But really speaking, I wanted to make sure that how can we use this efficiently? That's the main premise for us. So as I started before the 7th step, I suggest you guys follow those 7 steps, find out the negative conditions and positive conditions, and have sufficiently large amount of data using generatedata.com. That'll be useful for you. Thank you.